Section 2. How water ionizers split water into two streams. One of the most distinctive things about a water ionizer is that it does not supply clean water only. It changes water through a process called electrolysis, creating two separate streams with different characteristics. A standard filter removes unwanted substances. A water ionizer begins that way with good filtration, but then goes further by passing water that's already been filtered across electrically charged plates that alter its chemistry as it flows through the machine. Now in this diagram here, you can see filtered water here going down through these plates. Here's two plates and it's going down. Being the alkaline minerals are being pulled over toward the cathode, it's called. It's the negatively charged plate. And then the acidic minerals are pulled over here toward the acidic plate. And then there's going to be oxygen rich acidic water for plants or for skin. They call it beauty water, hair, this kind of thing. And also sanitizing, I'll say, depending on how acidic it is. If it's below 4 pH, it would be sanitizing water. So that's the purposes here. And then the alkaline rich water at different levels you can select for different purposes. So if you just want lightly ionized or a little bit more, you would choose different levels on your water ionizer machine. So that's how that works. And what happens inside is well, I already described what happens inside, but basically water molecules participating in this electrochemical reactions and splitting into two streams like this, there's hydrogen gas generated at the cathode side where the alkaline minerals are concentrating and it's negatively charged. So hydrogen gas is important. That's your molecular hydrogen. And these ions enter the alkaline stream. And acidic forming ions will go toward the acidic side, as we already mentioned. The dissolved minerals shift differently within the chamber, and it really does depend also on your source water and whatever setting you choose and the flow rate you use, how concentrated the alkaline minerals will be on that alkaline side. Okay, and then some of this I'll just let you read yourself because it's really a repetition of what I just said. Many water ionizers have separate settings. I mean, pretty much all of them do, for drinking water and acidic water. But usually that's not really necessary all the time because both streams are produced while you're ionizing the water. And so you can get your acidic water out while you're pouring your alkaline water. I mean, why waste the water? And that's the way I think about it. There's also the little button or option where you can just get filtered water out of the machine. So the water ionizer works in a wide variety of ways. Now, here's a little section on the basic chemistry behind the alkaline side. And this is the chemistry that Dr. Ota was focusing on. So in goes two H2O molecules, and then it is exposed to the electrode, which is negatively charged, and out comes hydrogen, H2, and two OH, negatively charged molecules. Now, of course, you've got your dissolved electrolytes in there that will also have this negative charge as well. But that's the basic principle of what happens and the chemistry behind it. And uh, it also shows why the water becomes more alkaline, because hydroxide ions increase on that side of the chamber, which is going to uh, increase the alkalinity. So that's your hydroxide. Okay, now why minerals matter. Electrolysis depends on conductivity, and conductivity depends largely on dissolved minerals in the water. Water that's completely void of minerals, let's say distilled water, cannot be ionized this way. It's too low in minerals. Electrolysis will not be able to happen, or it would be less efficient, let's say one or the other. This is why ionizers do not perform well with very low mineral water. Most municipalities around the country do have enough minerals to ionize, unless you are hooking up to a reverse osmosis or something like that, in which case now the minerals have been stripped out of the water. So there's a page for that. And I should just at this point show you that, or I think I have already showed you that. But this water ionizer use and care page becomes extremely important to all people who are going to buy a water ionizer. Just read that page. All right, so now here we're back to why minerals matter. All right, now on the opposite end, so you can have too few minerals, in other words, that's bad. Can ionize. And then also on the opposite end, water can contain too many highly conductive minerals, like sodium. So when it's using water that has been put through a sodium exchange softener, there are definitely some issues that are brought up for water ionizers, and I don't recommend that. You need to remove the sodium. So maybe if you have to have your water softened, or if there's nothing you can do about that, then remove the sodium. The only thing that's really going to do that is reverse osmosis, and then go ahead and remineralize your water, the reverse osmosis water. I know that's a lot of steps, but sometimes people's water are so extreme that they have to go through a lot of steps, and it's just one of the things that I'm bringing up to you, that you know you should know in order to understand the chemistry here. So sodium will what's wrong with sodium? It is going to make the water ionizer way too highly conductive. It's going to be crazy. It's going to go nuts. Too high electrical conductivity is going to wear out that machine. Number one. Number two, sodium has another odd thing about it, in that it tends to uh, you know, get uh, strip strip the platinum, or it has a I'm trying to think of the word for it, um, but anyway, it erodes. It has a corrosive, eroding effect on the platinum. Now, nothing's going to erode the titanium. That's a very, very super great mineral to use for the plate. But the platinum is necessary on these water ionizers if you're going to catalyze the electrolysis process, which is just basically another way of saying speed it up enough to be able to work. With this is fast action ionizing. You're pouring the water through, in it goes tap water, out it comes ionized. It's an instant thing. So you need the catalyzing effect of the platinum in order for that to happen. You don't want that expensive platinum eroded off the plates. And besides for that, there once it's all put together in a package in your product, you can't remove, you can't open up the plates and recoat them with platinum. It's just not, you just have to buy another machine. So you don't want to use a sodium softener. Or if you do, get rid of the sodium. And there you go. All right, now um, the common dissolved minerals that contribute to good ionizing of water are things like calcium, magnesium, potassium, and even some sodium. These minerals influence the pH range the machine can produce. And when water leaves the electrolysis chamber, it's measurably different from the filtered tap water that entered the machine. And depending on the machine, and source water, and settings, the alkaline drinking water may differ in taste or feel, in addition to health benefits compared with ordinary filtered water. So, just plain English, the water ionizer filters the water and then uses electricity to separate it into two different streams, one becoming the alkaline drinking water, and then the other one becoming acidic stream with its own uses. During this process, the water changes in several measurable ways, including the pH, hydrogen production, mineral balance, and electrochemical behavior, with a negative charge and greater concentration of electrolytes in the alkaline stream. Okay.